Hello YouTube, welcome to BPS Explore. Today is the first video of learning MicroPython series. As it was the first video, so we are just going to see all the overview of this complete series. MicroPython is nothing but a Python based language for microcontrollers. We'll learn everything about MicroPython in the upcoming versions of videos and basics of microcontrollers. And also I had included basic electronics with the help of coding. So we explore many things in this series, so stay tuned. All the codes will be available on my GitHub page, but the link is below, so the whole sets are here, so everything will be available for you free on my GitHub page. So I had given everything, the technical documents for ESP32, because for the whole series we are going to use this ESP32. Wait a minute. Okay, done. So this is the technical reference for ESP32, so you can read it, or pin reference, so you can search the pin reference here. So I had given everything that you needed for here for the series. Mostly if you are learning a Python, so whatever language, so mostly if you are learning anything, all you need first is an environment. So here I had given a links for all the environments. So mostly wait a minute, so this is official site for MicroPython, where you can visit and download firmwares. So MicroPython works with firmwares. Okay, then so just go to, you can also use it a web-based editor. There is also a web-based editor available on there. You can test a PyBoard which is specially designed for Python, and in download sections you can find that all the available boards for MicroPython. So MicroPython don't have many boards like Arduino or other or C. It has only some sort of boards. It has a small circle of boards, and one of the cheapest is ESP32 that we are going to use in this series. So I am using a dev kit for that, which is nothing but ESP32 W room dev kit. So this is the board that I am going to use for the whole series. And also I had a board of PyPico W, so you can also use PyPico W2 for the series. So 95% of the program covers with this ESP32, and only 5% of this covers with this ESP32, that PyPico. So these are the boards that are available. So maximum it has boards of STM32. So MicroPython was specially designed for, originally designed for ESP32. The first version of board comes with a microcontroller of STM32. Okay, done. So this is official page. The next thing is that IDE, so environment. So if you are new to MicroPython, then I personally recommend to use Thorny IDE. So because it's so eco-friendly, it's so easy to learn, so easy to use, it will be more friendly. So it was more easy for the beginners to use. Wait a minute, I think my network was little slow. Yeah, okay, done. So you can download the versions here, or you can use pip commands to download, like pip install Thorny. So it's also available there. You can also use pip install Thorny. Here it is available, so you can also install it through pip commands. I'm just going to show you how it looks like. Okay, this is how the Thorny versions look. So totally it has the same functions. So here you have to choose which controller you are using. If you don't have a controller, you can also use this as a local Python variant. So what I'm going to do is that I'm just going to configure interpreter. So if I don't have any kinds of board, then I can use local Python 3, which doesn't need any MicroPython controllers or any type of controllers. It runs as a normal Python language. So this is how it works. and you can edit the formats according to your wish. So if you want something, so you can use. And one thing that which is more I like in this is that installing a firmware. It was more easy to install a firmware, so you have to choose the board which one you are going to use. So for me it's MicroPython ESP32. So all I needed is that to choose this which port I'm going to use and then install it. And one thing that helps more in this is that if you are using Tony, then you don't need to download the firmware from the page of official MicroPython, because what it do is that it automatically downloads. So the according to this IDE automatically downloads the firmware and upload it to you. Okay, so I'm just cancelling it because I had already uploaded it, so I am cancelling it. This is how the whole things look. Second, I recommend using PyGraft, so which will be easy to use, which is a lightweight IDE. Doesn't need more things. All you need is just to install Python. So you can download here through this site. So from here, okay, and so for Mac OS or for Linux or for getting started with, so you can download it from here, from Windows. So you can get it from here. And I personally recommend, so one of my first recommendation for IDE is Tony, but second I most like to use is this Adafruit AMPI module, which is Python module especially for microcontrollers in Python, MicroPython or CircuitPython. So you can run both with this MicroPython or else CircuitPython. So this is a page how to install Adafruit AMPI module. So you just need to run this command, or you can go with the following rules according to your system, or you can get the clone of that and just install it as your wish. Lately so second I show you how to use this. So this page this link shows you how to use that. Yeah, so you had installed it. So already we had seen that. So this is the one, so you can list the number of ports as like that. This runs completely in both Windows and Linux system, so no problem which system you are having, or Mac. This is the type of command I love to use, because you don't need to upload the file to the code and wait for the time that taking to upload codes to the file. All you can do is that you can run it from your system without uploading the code directly to the microcontroller. I will show you the demo of this thing by how to use an AMPI module that I love to use always. So I am clearing my terminal. So I am activating my environment as Linux. It will be like so I had activated my environment and I am giving permissions to my ESP32 board. Okay, done. So I'm going to use AMPI module now. So what I'm going to do is that I'm just going to list the files that I had already uploaded on my ESP32. So just you can use a single hyphen and a P, or you can also use double hyphen and you have to type port. So I'm using a single hyphen and P, and I'm going to type the port name. On the list, to get the list of files is that ls. So what this command do is that this command gives me a list of files that are in my board, with the board. So these are all the files that I had on my boards. So I can also get this program very easily. This was so friendly. MicroPython is more friendly. just all I need is that get command. So I need to run the boot. So now I'm getting the boot.py file. So which file you needed, you can get it. So boot.py. So I'm getting the file that. So what this thing do is that this thing completely prints what are the things in the, what are the codes in that file. So these are the codes that are present inside the boot file. So this is how the whole system works. So if I want to run something, and one of the main thing that I allow to do with this module is that you can use any module, any IDE. So this is VS Codium, which is a looking like of VS Code. You can use VS Code, VS Codium, or in Linux if you are more interested in NVM. So in Vim editor. So what I'm going to do is that I'm going to run a file with the Vim editor. So just wait. So I'm opening this blink.py file in a Vim editor. Wait a minute. So there were some errors on it. Okay, done. Editor mode. Okay, done. Okay, so what I'm going to do is that I'm just going to run this file into, so I'm placing my things on it. So I had made an LED on my 13th pin. Wait a minute. By port name there USB 0, and I'm going to run blink.py. So what this one going to do is that now you can see that LED is blinking. So I'm just running the blink program without uploading into this board. So if I just press the reset button, then the program completely stops because the code is not in this board. The code is running directly from my PC. This is the only thing that I love most in this thing. And one of the things that I love to do in this is that okay, wait a minute, I'm just lowering it. Okay, so I am quitting it. Okay, done. So just clear the terminal. And one of the main thing that I love to do is that in AmpI module, so I don't worry you are using, so one of the command that in, okay, I'll show you this example and show you that in Linux you can actually use a terminal screen module. So I'm going to give up my baud rate. So what this one do is that this one completely, so I'm having my terminals, which means I am directly now interacting with my microcontroller. So I'm not getting to anything other, so I'm directly interacting with my microcontroller. So what I can do is that wait a minute, I just open my camera. So it's a Python file to open up a camera. So what I'm going to do is I'm just opening up my camera, so you can hear, you can look at that. I'm going to from mission message pane. I am assigning LED. Out. So what we are going to do is what say is that now the LED is off. So what I'm going to do is that I'm going to make it is on. So LED dot value. So I'm going to give it a value of 1. So what it do is that it will directly changes itself. So you can see that the LED is on. So if I give them that LED dot value 0, so it directly turns off. So what I'm doing is that I am directly interacting to the microcontroller from my system without uploading anything. So this helps me more in error debugging. So I can run each line, as Python is an interpreted language, so you can run this by line by line. So I can find where the error in my code is. That it helps me a lot. It's only available in Linux system, but one thing that I love to do in this AMPI module is that you also have the same command in AMPI where you can use it in Windows. I will show you that. Yeah, okay, done. So it will be like serial dot min term. It's a list of things, not here. It's a command to run. If you are on Windows, it will be like comp3. So ampy hyphen port, it will be here comp3, comp4, or whatever according to your case, and you have to run get or whatever command you can do according to your need. So this is the put command. So what it do is that it puts a file from your system to the microcontroller. So it uploads it. It was like uploading the program to the microcontroller. And here is the interactive repo. And this is the command I told you that. This command, this Python mserial tool min term raw. So not so this command, what it do is that you can directly interact with the microcontroller like what I did in my system. Stay tuned. You can learn lots of things in this series. There are way more things, especially the digital level program with these microcontrollers are so interesting. So just tuned, subscribe my channel and wait for every video. So hope you get plenty of knowledges in this video about all the things we cover, all the basics of electronics with the help of science. So stay tuned and subscribe my channel, and let's hope everything will be fine.